Okay, welcome back. I'm going to do something right now that I tend to not do. I'm going to give you a formula that I won't justify. I won't tell you why it's true. I'm going to tell you what it is, and I just want you to believe me. If I find the surface area of a cone, or if I'm trying to find the surface area of a cone, the cone has a radius of r and a height of h. If this is the case, the lateral surface area is pi r times some quantity called L. What L is, so L is something called the slant height. So you noticed that, with the pyramid probably too, that there's a difference between the height if I measure straight up and down, if I go from the base straight up to the apex, versus if I sort of look on a slant here. And so this distance has a name, and that distance right there is the slant height. So you will notice that the slant height is the hypotenuse of a right triangle. So you will notice that I can always set up this as a true equation using Pythag. Alright, so the lateral surface area of the cone, pi r L, which means if I want the total surface area, well, you can probably figure this out. Lateral we just talked about, that is pi r L, plus whatever the area of the base is. Well, what shape is the base? Circle is hopefully what you said. What's the area of a circle of radius r? Pi r squared. This formula, unfortunately, is not given to you on like IAs and whatnot, but it is up in the room. So just take a moment, find out where the cone visual anchor is, and you'll see the TSA is right there. And in case you're like getting impatient, I will show you where this pi r L business comes from in just a minute, but first I'll have you work through some examples. Then at the end of class, I'll bring us all back together and I'll tell you all about it. So this is an example that you have to draw yourself. I'm so sorry. And we will find the total. Let me just put that in here. I want that to be the total surface area of this cone. So set up what you think you need. Hopefully you annotated the question a little bit, just out of old habit, and you noticed that TSA is LSA plus the area of the base. Well, LSA we just talked about, it's pi r L, because we're dealing with a cone, plus the area of the base. Well, that's a circle. So let's plug in what we know. So radius is given to me, that's 6.5, that's right there. But I don't know the slant height, it's actually not labeled, alright? But fortunately they did give me the height of this cone, so without too much work I can probably figure out what L is. Hopefully you're all shouting in your heads, use Pythag. Okay, don't yell at me, I will. Take a moment, solve it, and see what you get. If you're like me, you got 11.9 when you square rooted 142.25 or thereabouts. So now that we know what the slant height is, so we got pi times 6.5 times L, well that's a terrible parentheses, times my slant height, which is 11.9, plus pi times 6.5 squared. Alright, I'm going to zoom out and actually calculate this. So take a moment, just remember that was a separate calculation. What does this end up giving us for our TSA? I myself got 375.7 square centimeters. So that would be our total surface area of the cone. Take a moment, you can look at this example. It's 1C, it's given in your ICW. At this point you probably feel confident doing it yourself, but if not, just listen and learn, or watch and learn. Again, I think they really meant to say find the total surface area. So what is total surface area? Hopefully you're thinking that. Blah. And so this is a cone. And please make sure it's clear in your head, why are we just saying pi r squared and not, for example, like 2 pi r squared like we did with a cylinder? Hopefully you're thinking, well, with a cylinder you actually had 1 and then up here 2 circles. That's what a cylinder had. It had 2 circles. Cones just have 1 circle. That's why there's just 1 pi r squared. All right, they give us L. They give us the slant height because they don't want us to do, I guess, that much work. And they give us the radius. So let's just plug them in. And that is what I got. Wow. At this point, you are actually done with the video, so you can turn it off or rewatch any part you need, and just start working on some cone problems. I just wanted to show you like a super hard question. So this is just, if you've gotten everything and you've paused the video and you've done cone stuff and you've looked at your exit ticket and you're just like the grand master of all of this, here's a question that will hopefully be a little more interesting to you. So again, right now, if you are watching this, you've already worked through pyramid and cone surface area problems in your ICW, and you're totally confident. So now you're ready for the next level. All right, here we go. What you'll notice about this that is difficult or is tricky is that the base is not a square. It is a rectangle. If that's too hard for you, you should probably pause this video at this point and just not watch anymore. No, I'm just playing. All right, so it's a rectangle on the bottom. So if you notice, the tricky part is if you look at this lateral side, this lateral triangle right here, this face, this triangle has a base of 4. If you look at this triangle that's also lateral, it has a base of 6. That means we have triangles that are lateral sides, here's one, here's the other, that are not congruent. In other words, that peach triangle and this pink triangle, these colors are so similar, all right. And this pink triangle are not congruent. So I can't take the area of, for example, this, what color did I say this was? Peach. This peach triangle and multiply it by 4, because there aren't 4 peach triangles. How many are there? Hopefully you're thinking there are 2. They are across from each other. One's there in the background here, and one's here. So there are 2 peach triangles. Well, how many pink triangles are there? Again, I can't take the area of a pink triangle multiplied by 4 because there aren't 4 of them. There are actually 2 of them. 2 pink triangles, just across from each other. So the TSA then would be 2 times the area of the peach triangle, because there's 1, 2 of them, 2 times the area of the pink triangle, plus the area of the base, which at least that's nice, it's just 4 times 6. So now the question becomes, can you calculate the area of the peach triangle and of the pink triangle? For no particular reason, I'm going to focus on the pink triangle first. You may recall, here is the height of the pink triangle, so it goes down here to here. Boom. So that is the height of the pink triangle. So if I want this height, again, I run into the same issue I ran into before. I do have a right angle, which is nice, because the height of the pyramid is 5.6, goes straight up from the center of the rectangle. But now I need to know what exactly is this height, because once I know what this height is along the, let me just put the pink back in so you can see which triangle I'm talking about. That side. So this is the only thing you're focusing on right now. So once I know the base is 6, I'm looking for this height. And again, to find this height, I'd have to use the Pythagorean theorem. I know this is 5.6. How long is this? Well, if this side is 4, this side should then be 2. And then this pink height, I'll call this h sub 1, I could find using Pythag. Do it out, I think you'll get this. 5.9 as the height of the pink triangle. Okay, that's nice, but we still need to find the area of the peach triangle. Keep in mind there is the peach triangle. So let's see if we can find out what the area is. Well, to do that I would need to know the base, which I do, it's 4. But I also need to know the height, which I don't even have drawn in, so let me draw it in. And I'll call this h sub 2. So the height of the peach triangle is h sub 2. Well, I don't know what it is. How could I find it? Aha. I can use the Pythagorean theorem, because again, the height of the pyramid goes straight down, forms a 90-degree angle with the base, and that makes this height, my slant height, or my height for my lateral triangle, makes this the hypotenuse of a right triangle. So I can set up 5.6 squared plus whatever this is squared equals h sub 2 squared. Well, how long is this? Well, if the side here is 6, then this, you notice I'm taking half of it, should be, hopefully you were thinking, 3. That means I can set up Pythag one more time. I got this, which I believe if you solve it out yields 6.4 for the height of the peach triangle. So now I know the heights of both triangles and the bases were given. So I think I have enough to set up my TSA to plug in and find it. Take a moment, knock yourself out. You can do it yourself. I'll just show you the final answer here. I think we end up getting, I cleaned this all up, and I got 85 square meters. This is a really hard question, hence the name super hard question. If you manage to watch this and actually understand it, then you are a giant among men. Have a great day.